In our last lesson, we learned about ionic compounds. It turns out that ionic compounds always have to be neutral. That is, the amount of negative charge the anion has and the amount of positive charge all the cations have has to balance out. And in this lesson, what we're going to do is practice writing neutral ionic compounds. So we're going to start with a particular cation and a particular anion, and we're going to see how many of these do we need to make our compound neutral. Let's learn to do just that. Let's say we have aluminum and oxygen. So that's the two elements that we know are in our ionic compound, but we don't know how many aluminums there are or how many oxygens there are. And that's the whole goal. We want to figure out how many aluminum or oxygens there are. So the first step here is to predict the charge on your ions. And you'll do that from the periodic table. So if you go to the periodic table, the columns tell you the charge. And I'll link to a video below that shows you how to do that. But the column for aluminum gives me +3, and the column for oxygen gives me -2. Now, sometimes you have to know the charges from memory. That's true for what are called polyatomic ions. Polyatomic ions are ions made up of more than one atom. And they have a charge that you can't predict. And that means you just have to memorize it. So in all chemistry classes, you have to memorize a list of polyatomic ions and their charge, which can be kind of a pain, but is necessary to do problems like this. Okay, so this one we know from memory, and what we want to do is we want to figure out how many aluminums do I need and how many oxygens do I need to make them balance out. First, I'm going to do this with a trick little math technique where we do what's called crossing over, and then I'll explain why this works. So we cross over, and that means our aluminum charge becomes the number of oxygens, and our oxygen charge becomes the number of aluminum. So that's why it's called crossing over. And so what that means then is our aluminum has 2 that came from the oxygen charge, and our oxygen has 3. Okay, so the reason that works is because it makes our compound neutral by taking advantage of the fact that basically, if I have 2 things at +3 and 3 things at -2, they're going to match. Let me draw that out. What I'm going to do here is I'm going to put 2 columns, and on the right side, I'm going to put oxygen, and on the left side, I'm going to put aluminum. And we're going to write their charges, so 3 plus and 2 minus. Initially, if I just have one of each, I have 2 minus and 3 plus. And our whole goal is to get these two guys to match to make it neutral. Well, if I have 3 oxygens, O2 minus, O2 minus, then that's going to add up to 6 minus. Now they still don't match, but if I take into account that I have 2 aluminums, that is going to make it 6 plus. So now those are equal and opposite. So that's what I mean by match. 6 plus and 6 minus cancel out. And so that's why that's a neutral compound. So that's our correct answer. There's one more step down here which we don't need in this case, which is we want to reduce those numbers if they can. So say, for example, that we got Al2O4. Well, I could actually reduce that and keep it balanced by dividing both by the smallest one. So if you can divide by the smallest one and you get nice whole numbers, then you do that. That would give me AlO2. So we reduce if possible. In this case, if I divide both of them by 2, 3 divided by 2 doesn't give me a whole number, right? So if I divide this guy by 2 and this guy by 2, then I don't get whole numbers. And so that means we don't reduce. But we'll look at an example in just a second where we do reduce. Okay, next one. Here we have magnesium and oxygen. So magnesium is +2 from the position on the periodic table. Oxygen is -2. Now we cross over and we get Mg2 and O2. All right, now we can see that we've predicted the charge and we've crossed over. Now we can reduce them. And that shouldn't be surprising because if we have Mg and O and they have the same charge, we only need 1 of each to make it balance out. So having 2 of each is also neutral, but the numbers are bigger than they need to be. So we'll divide both by 2 to reduce them. We just divide by the smallest number down there. And that's going to give us MgO. Boop. So notice, it's kind of like when you have a fraction that just can be reduced, you reduce it if you can. In the same way, we have magnesium oxide. 2 of each is neutral, but it's more than we need. 1 magnesium at +2 and 1 oxygen at +2 is neutral. Okay, now let's do one with a polyatomic ion. Here we predict the charges, or we know it from memory. Calcium is +2, we get that from the periodic table. ClO4 is all one ion, a polyatomic ion. So when you look at it, it might look like multiple ions, but it's actually just one, and that's what makes it one of our polyatomics. You just have to memorize that it has a -1 charge. So it has a -1 charge. And so once you've memorized that, we follow the same steps. We cross over, and we get Ca1, ClO4. Now here's where some people will get tripped up. Some people will put ClO2. But that's not right. Because that's not ClO4. That's a new polyatomic ion. Instead, we need ClO4. We just need 2 of them. How do we do that? That's where we use parentheses. So just like in math, we can use parentheses around our species. And if I put a 2 down there, what that 2 is telling me is I have 2 whole things in the parentheses. So I have 2 perchlorates. And the reason I write it this way is to communicate to everybody, hey, this is the polyatomic ion perchlorate, and I have 2 of them. So we got to use those parentheses. Now we reduce the numbers if possible. It's 1 and 2, so they're as reduced as they can be. All right, last example. Magnesium and phosphate, so another polyatomic ion. Magnesium, if we follow step 1 and predict from the periodic table, we'll get +2. Phosphate, again, you just have to memorize, is 3-. When we have multiple polyatomics, we always use those parentheses. So that's what we'll do here. We're going to write Mg, we get the 3 from the phosphate, and now we have PO4. I need 2 of those. So I have to use parentheses. Anytime you have multiple polyatomics, you use parentheses. And so that's a neutral compound. I can't reduce that anymore. I've crossed over, and I can't reduce it because I have 3 and 2. Okay, so thanks for watching this episode of Real Chemistry. If you have any questions, please ask them below.
Hey, hey.